A long time ago, in a galaxy far, far away, there was a very large impact called Caloris. And anyway, so take a look at Mercury here. This is a false color image, meaning a true image of Mercury where, depending on what type of light hit the camera, uh, the person processing this in a program like Photoshop would have colored the different parts, different wavelengths of light, different colors, so you can actually see features more prominently than if you just saw the boring old, normal Mercury. This might not even be true color, like you would see with your eyeballs, but it's probably closer. So when you look at Mercury in this false color image, you see this crazy big feature here. It takes up a huge proportion of Mercury's surface. And it's concluded that this is an impact feature, a very big impact feature, a very big object probably collided into Mercury a long, long time ago. And not only that, but if you look on the other side of Mercury, I couldn't find a good picture, but you see this weird terrain. It looks almost like ripples on water. And it's thought that the Caloris impact was so big that the energy from it would have traveled through the entire planet, through the huge core. This is the core. I'm going to talk more about the core in the next slide. This energy would have traveled through the core and around the mantle and created this weird looking terrain. And this large impact is known as Caloris Basin. Probably at one point was more of a crater looking beast, but over time, since this probably happened a long, long time ago, over time probably would have eroded away somehow. Maybe lava flows would have covered parts of it. So that's a pretty cool surface feature. So what about inside? That was the last of the surface properties. What about going inside? What's going on inside Mercury? Well, we have yet to send a probe to the surface of Mercury, let alone inside Mercury. So usually how we determine what goes on inside the surface of inside a celestial body like a planet or a moon is we put something on the surface like a seismograph, something that can measure the earthquakes of the object. But we haven't done that on Mercury yet. So we have to use other means to kind of guess. And through those other means, evidence points to the possibility that Mercury has a very large core in proportion to its radius. What do I mean by that? Well, if you look at the Earth's core, and this is probably not drawn to scale, but you can see that it's maybe a little more than half the radius of the Earth, whereas the Moon, its core is thought to be way less than half. Mercury, you can see, it's thought to be way more than half, so it takes up a majority of the inside of the planet. It's thought that part of the core might be molten. Actually, astronomers used to think that it was Mercury is solid, like cooled off and just solidified. But we've determined that Mercury has an appreciable magnetic field around it, and there were a couple prevailing theories. One was that, well, maybe when it was molten in here, that there was a magnetic field, and as it cooled, that magnetic field kind of froze in place like a permanent magnet. But the thing is, with the messenger probe that was sent there, it looks like the magnetic field fluctuates over time, and what that means is that theory is probably not quite as accurate, and it's probably more of like a dynamo effect, similar to what we see on the Earth. It's thought that the Earth's magnetic field comes from the fact that there's a molten core and maybe a solid inner core that rotates in relation to the Earth as the Earth spins and all that good stuff, and that like difference in rotation would cause a magnetic field. So possibly Mercury has somewhat of a molten liquidy core still that creates this weak magnetic field. It is definitely weaker than the Earth's. Maybe the fact that Mercury rotates so slowly, rotates 3 times every 2 orbits. That might account for the weakness in the field strength. It's thought that the quicker the rotation of the planet, the stronger the dynamo effect, and the stronger the magnetic field. But it's an interesting little feature of Mercury. And a little bit about the history of Mercury, and this is going to be it. So basically, Mercury is a geologically dead world. It doesn't have any tectonic activity, doesn't have any volcanoes, might not even have any earthquakes. Really doesn't have much of anything going on. It's geologically dead. So the only thing that would change the surface is an impact, which would make a crater. Maybe the solar wind over time might do some very slight erosion or even breaking down of surface particles, but that's probably not that much. Although since Mercury is closer than any other planet, it might be more than a typical planet. Its mantle, which is most likely thicker than, say, the Moon's mantle, uh, probably prevents any volcanic or tectonic activity. And Mercury probably cooled more slowly than the Moon because it's bigger. It takes longer for bigger things to cool down. If you have a cup of coffee next to a tub of water, let's say and they have similar shapes, like a cup this shape and a tub of a similar shape, then the smaller amount of liquid will cool off more quickly because there's not as much energy in there to cool off. Although you can change the shape of the tub or whatever, and that would alter the experiment. But anyway, since Mercury is a bit larger than the Moon, it probably cooled off more slowly, which would have allowed for more early volcanic activity that covered a good number of the craters. Whereas the Moon would have cooled off more quickly, and as it cooled off, less volcanic activity would occur. Because volcanic activity comes from molten liquidy magma, and as you cool off, that just freezes, it hardens. Ironically, though, the cooling contraction, as Mercury cooled, it contracted. That contraction probably squeezed off any volcanic activity. So you got like a volcano, right? Well, let me draw it this way. You got the before surface of Mercury, and maybe some like a plume going up that led to a volcano. But as Mercury cooled and compressed, material here would have squeezed this shut, stopping any volcanic activity. So ironically, it's thought that this cooling contraction would have closed off volcanic activity maybe even earlier than volcanic activity ceased on the Moon. So even though there might have been more volcanic activity earlier, it might have got shut off sooner. So uh, these are all tenuous theories. When you know so little about something, the theories are definitely weaker until more and more evidence starts to pile in. And the only way that can happen is to send more probes. So I don't think sending people to Mercury is feasible in the near future, or maybe even the medium future, because it's so close to the sun. Just getting something that close, you got really bad radiation dangers and all that good stuff. Although at some point, probably this year, we might show the movie Sunshine, which is kind of a weird sci-fi space horror movie, but it has some interesting ways that they deal with getting closer to the sun. But anyway, that's for the future. For the present, I am done with Mercury, so good luck. You can take the quiz next. Talk to you later.